thank you again, everyone, for being here. It's just a pleasure to be here on this. I'm losing track of the day because it's such a busy conference, but good to be here on this Tuesday with you all. I want to take just a few moments then to build on that, on where things might be headed. We're in the AI exhibit hall here. We're seeing lots of innovation, lots of exciting titles of products, maybe some buzzwords, and hopefully we can put that into context in terms of what we're seeing in the near future and what we kind of need to see that happens next to make this actually. So this is where we are currently. We have this growing portfolio of solutions, right? We have imaging AI, we have non-imaging AI, we have large language models now not on here, our foundation models, right? All the good things that we want. And we'll talk about agentic AI with due time here as well. But what we're seeing is custom integrations for different use cases, right? If you think about the more common ones, pulmonary nostril detection, brain bleeds, MS detection, ARIA, other things, fractures, and coronary artery calcification quantification, you may have separate, discrete algorithms and solutions for these that you then have to integrate at a single viewer, or maybe you don't. Maybe you have multiple viewers that then you have to click out to. And then if you think about it, what we're seeing all of a sudden is that instead of actually being efficient and making our jobs easier as radiologists, AI actually tends to add more burden. We're making more clicks out of our workflow. We're trying to look for things that we don't know to expect, or we don't know where to find them, or that we should even be thinking about them. And when we find it, we may not know what to do with it. How do we interpret it? What's the purpose or the intent of that use case as it's presented? And the next step, we have to manually dictate that information after distilling it to a report. So we're still seeing this really chaotic, hectic system. But if you look at the underpinnings of all this, we have some friends here. We have standards. We have our DICOM secondary captures, our structured reports, HL7 FHIR. These are all the building blocks and the bread and butter that will then help us achieve the next state, which is where we need to be. So Lars, if you can click the slide for me, this is where we're headed right now, is having things seamlessly integrated into a single platform. And it could be by modality, by anatomy, and then allows the radiologist to have a single point of contact where they can accept, reject, or modify the results. And if I could ask for a little bit more, with the help of our standards that we've seen, synergizing with our reporting solutions for that seamless transfer of information, whether it's quantitative details like measurements for looking at tumor burden or tumor size, the volume of white matter lesions, for example, or if we're looking simply for things that are binary, the presence or absence of findings as well. But at the end of the day, what we want to see, and at least what I want to see and I'd advocate for, is that very low burden on the radiologist to then review the report for the AI results, not having to click out to multiple windows to find it, not having to click out to multiple widgets or other ways of viewing this information that really should be in the report, where we can confirm, focus on the images, on the complex findings, and then send this off to our providers. And next slide, please. So that's where we're hopefully headed for that streamlined reporting. And that's why I wanted to show, again, that report that Dr. Doshi had shown, because the key here is also those standardized reporting templates. When we think about there are several things to think about here. First is, if we were looking for that streamlined reporting, we need to have integration of standardized templates, but what that also means is common data elements. So common data elements that we'll talk about in just a moment that capture exactly that machine consumable, but that human readable content that aligns with what our clinicians want. So if, for example, for ARIA, we have defined guidelines for what to look for from the ASNR and other big groups from expert consensus. And so it would make sense to then incorporate these directly in the report, and for our models to then essentially plug in that information to those discrete fields. And this, again, allows an easier time, hopefully, for the radiologist to interact with AI. But more importantly, I think, for that consumer, the clinical neurologist on the other end, who's in the neurodegenerative clinic, for example, looking for findings of ARIA, to know exactly where to look for changes, whether to see that actionable finding, that there is a worsening ARIA-H or ARIA-E that needs to then lead to that medication being stopped. And I think our key here are these standardized templates. And so it's a little hard to see with a small texture, but you'll see discrete areas, discrete fields for those findings as defined by the ASNR templates, again, with expert consensus. The way I read an AI result, there's no guarantee that the next person is going to read it the same way unless it's a very clear, defined presentation and some instructions there for the end user. But these templates take that onus off to some degree, and it helps essentially seam those gaps, allowing us some standardization in how we report these findings. So where are we going with Gen AI then? We know we want to hear about generative AI. And so just to be clear, Dirk told me we're not selling a generative AI product here just yet. So we're not going to go into that feature yet. But what we're looking at is a really quick progression of things. And so I'm giving you a short snapshot of what we're seeing, at least in the research, because I think a lot of this does align with the products that we're seeing here at the show floor. So in 2022, we had ChatGPT that really revolutionized the way we look at large language models. But large language models have been around. We've had BERT, we've had RadBERT, other large models that were not as accessible, and we couldn't do much with them at scale. But now since 2022, 2023, we've seen all sorts of use cases and advanced technology, advanced models and iterations that have enabled things that get us to that future of imaging reporting. So in April 2023, we started talking about extracting structured information from free prose text. So you can imagine as it pertains to multiple sclerosis or ARIA, you could dictate in free prose, but as long as you have those common data elements that define the things that you want the clinician to know, that you want the AI model to report, and then that you want to monitor for things like drift, as we talked about in the prior talk, using a large language model provides a really streamlined way to extract that discrete information. And then we talked about, well, why don't we go one step further and generate impressions? We've all heard about impression generating tools quite a bit from various perspectives here, and large language models are powering those as well. And then we said, well, let's go ahead and make it a shared effort between both the commercial and the proprietary models and open source. So all of a sudden we're seeing not just one use case, but multiple use cases that are really aligning with what the radiologists want, but what the clinicians want. And then looking at how we can expand this away from just a single model to allow some more flexibility for places that may be resource constrained and need to rely on those open source models there. One more slide, please. So then also on October 24th, then just kind of keeping up with that, we advanced a little bit more. We asked our models to help generate differential diagnoses, and now we're getting into more of that supporting our decision-making abilities as clinicians. And we started talking about, well, can we then scale this to making the full report, right? We're talking about foundation models and vision language models and actually being able to generate report text from looking at the images. To the point where now we're really thinking about those nuanced use cases that not just perform those at scale, but can help with things that radiologists actually want, right? Detecting errors, detecting missing information. I mean, can you imagine if I'm dictating a report on ARIA and I forget to talk about prior microhemorrhages? Well, what if the model could prompt me and say, hey, I see you're describing the findings for a patient who's on this medication, and it sounds like you're talking about ARIA-H, but you forgot to mention this detail. And this is where we are now, and this is where the field is. And so just, again, including these references, because I think these are great reads that establish the foundation for where the current state is and the current thought leaders are projecting some of the ideas, but talking more importantly, those potential challenges. And I use this as a segue because we've talked just a bit about vision language models and the future with reporting there. Again, relying on standards to get from the vision language model results to the actual report text. But on the next slide, we're going to touch briefly on another really important area that we're going to see, and that's agents. And so all this kind of gets at that initial image of streamlining and decreasing the burden on the radiologist to interact with AI. I mean, the idea of having an agent that can then call out to different systems. So the radiologist makes a query, right? The agent then enacts a series of steps based on the resources that it has access to, whether it's a reporting software, whether it's online resources or guidelines or other tools, to where this is a little more general, right? This is from a paper published in Diagnostic Interventional Radiology, where they talked about the potential future and what the scope and breadth of interactions of AI agents with other systems in the healthcare environment look like. But I would say when we talk about radiology, we can actually make this a little more nuanced because it doesn't have to be this broad scope to where we're trying to accomplish a million things at once with one agent. Agents can talk to other agents as well. But if you ask me, we may be looking at the next slide, which is a little more nuanced for radiology reporting. It's a little more simple, but you can imagine a radiologist, and this could be someone who maybe they haven't had as much experience with ARIA. ARIA is still relatively new. I think in academic centers, we often see this quite a bit. We talk to our clinicians on the neuromuscular side of things and the neuroautoimmune side of things, and we know about what we want to report. But in areas where those resources are constrained, we may have a radiologist who interacts with an agentic-driven reporting system that then calls out to the ACR, it calls out to the ASNR, it calls out to the RSNA. It may even call it to Radiopedia, or it may even bring back common data elements and then tell it and then integrate all that information and then work with the radiologist to get to that evidence-driven report that's more complete than it would be otherwise. And again, the idea is that these agents work synergistically in the background for a very low footprint in terms of the effort that it takes for the radiologist to interact with this really new technology. This is all a lot of projection here. It's really a lot of wish list. It's almost Christmas, right? I'm making a Christmas wish list here. But what I'm trying to say is I think hopefully we see some shared visions here. And what we need really for all this to happen is a clinician-driven focus. And we are clinicians as radiologists. So my call to action is work with the vendor teams around you and make requests for what those targeted use cases are so we can develop these future technologies with a patient-centric, a use case-centric focus rather than the other way around. Now, if we can go to the next slide here. Almost done. I just want to talk just a bit about common data elements and reporting guidelines. And so we talked about common data elements. We can think about these as a clinical question with a targeted response. And so we won't be able to talk about it in quite a bit of detail here, but if we go to the RAD element website from ACR and RSNA, you can actually browse a category of a growing portfolio of common data elements for various use cases. But the idea is This is the bedrock or the foundation that generative AI applications can actually draw on to extract content from experts that inform what our reports look like, what additional downstream intelligent actions look like triggered by the information in the report. I don't think our reports should be static. I think that if we say that there's positive ARIA, that should trigger a message in the EHR or other alerting system to the neuroradiologist, to the neurologist on the other side, who can do something with that information. But it all depends on how we standardize and structure things on our end, on the back end as well. And the common data elements, as you'll see, offer a really nice way to have machine-coded content in a human consumable fashion. And lastly here, if we're thinking about large language models, this is a plug for up-and-coming guidelines. My conflict of interest is that I am a co-author on this new guideline that we published in association with the RSNA and the Korean Journal of Radiology. The MyClear guideline provides this list of things to look for when you're looking at large language models in research. But I don't think it's just for research. As you go around to companies and to groups talking about large language model driven solutions, take a look at this list and try to ask those questions, right? If you're giving me a model that summarizes the EHR, well, what prompt are you using? What system prompt? Is it reproducible? If so, what is the, how often and how many times did you have to send the same prompt, right? All the information is here, and I think it can be really a resource as we start to see more and more on this frontier. And final thoughts and acknowledgments here, just the future is going to include not just automated imaging findings or reporting, but downstream intelligent action is, I think, where the focus is. But we have a lot of work to do on the steps that precede that, starting with what we've talked about here. We're going to have to anchor in those standards to really focus on interoperability. And so if you have time, check out other ones that we haven't talked about, like RadLex, Common Ontology. So using the same words to describe the same findings across several contexts, different sites, different environments. And echoing what my colleague and mentor here has said, is collaboration is key with vendors, with ourselves as consumers, and the RSNA and other committees, and I'd say organized radiology at large. This is that chicken and egg game, right? If we don't ask, it won't come, but if it isn't presented to us, we may not know to ask for it. So my challenge is ask for it and get that process started off the get-go. Thank you so much again for your time. It's been a pleasure having your attention.